Hello everyone, in this video we're going to be solving an exponential logarithmic system. So we have two equations, x to the power y equals 10 to the power 6, which is a million, and y equals 1 plus log x. When the base is not written, it means base 10. That's how it's always been on this channel, if in case you didn't know. Some people use LG for different bases, so on and so forth, but those are not universal standards. So I'm going to use log, sometimes Wolfram Alpha, I think always. Wolfram Alpha uses log for natural log, but I use it for base 10. Make sense? So this is base 10, and we have a base 10, so we're all good. Now, how do we solve the system? I'll be presenting two methods, and let's start with the first method. Great. So let's go ahead and rewrite the equation or equations. We have x to the power y equals 10 to the power 6 and y equals 1 plus log x. Let's kind of start with the less obvious method, which is solving for x from the second equation. Let's go ahead and do that. So here's what we're going to do. We're going to take y equals 1 plus log x, or let's write it as 1 plus log x equals y. I want to put the x on the left-hand side. It's kind of more natural. And then subtract 1 from both sides. Log x equals y minus 1. And then I want to do 10 to the power log x equals 10 to the power y minus 1. So we can do 10 to the power both sides. One of the things you should know with logs is if you have b to the power log x with base b, and this is always x. Make sense? So when the bases are equal, they kind of cancel out, sort of, and you get the answer like that. So here, this is base 10. So the bases cancel out, and we end up with x on the left-hand side. Nice. That's what's nice about 10 to the powering both sides, if that's a word. So x was written as a power of 10, which is nice because our first equation has x as in the base, and we have x to the power y equals 10 to the power 6. So that's nice. Let's go ahead and replace x with 10 to the power y minus 1. Okay? And that's going to give us 10 to the power y minus 1 to the power y equals 10 to the power 6. And guess what? You're going to end up with an exponential equation, which is fairly easy to solve. Okay, let's see what we can do. I think we talked about this in the previous video, which was 2 hours ago, and it said if you have a to the b to the c, then it's a to the bc. So you multiply the exponents. That's the superpower property. So now we're going to multiply y times y minus 1. Make sense? Let's leave it at that for now. You can also distribute if you want. I probably will eventually. And the right-hand side is 10 to the power 6. Now, don't write it as a million. It's better if you write it as an exponential with base 10. Now, we got the same base, which is super cool, right? So now we can equate the exponents. So y times y minus 1 should equal 6. Let's go ahead and write it as an equation. Y times y minus 1 equals 6. Now is a good time to distribute, or if you don't want to distribute, you can also think about it this way. Can I find two consecutive integers whose product is 6? And the answer is yes, definitely. Those are 2 and 3. Which one is larger? This one is larger, so this should be a 3, and this should be a 2. But that's not the only value of y that satisfies this, because if 3 and 2 work, -2 and -3, notice that the signs and the positions are switched. It's also going to satisfy the equation because -3 is 1 less than -2. You see the relationship? That's why it's not -3, -2. It's -2, -3. So if you get one solution, you'll get the other one automatically. That's a nice, cool trick. And they don't have to be consecutive. They can also be non-consecutive, or there can be like 3, 4, 5 apart. You could still use the same strategy. Anyways, y equals 3 and y equals -2 are the two values that I'm going to be considering. All right? I don't care about y minus 1. But what is y, and why did we use y? You know why. But y is 1 plus log x. Yay. Okay, it was given, right? So y equals 1 plus log x, and that's equal to 3. From here we get log x equals 2, and remember the base is 10, and by using definition of logs, x becomes 10 to the second power, which is 100. So one of the values is x equals 100. Well, did we say this equation is going to have a single solution? Nope, there's another one. And that comes from y equals -2. We already taken care of the y equals 3. So now y equals 1 plus log x, and that's equal to -2. And if you subtract 1 from both sides, you get log x equals -3. Now x is going to become 10 to the power. Remember the definition of logarithms, very important. It's pretty much the essence. X becomes 10 to the power -3, and that can be written as 1,000th with the th. 1 over 1,000 if you want to write it that way. Okay? So those are the two x values, and this brings us, not to the end of this video, to the end of the first method. All right, let's go ahead and take a look at the second method. And you probably guessed the second method already, but I'm going to go through that anyways. So we have, okay, what do we have? I have x to the power y equals 10 to the 6, and y equals 1 plus log x. Now they tell us that y is equal to something. So why not substitute that directly here, right? Just replace y with that. I mean, it's a more direct way, but first method was kind of like more indirect. Okay, so first method didn't use logs much. It just used the definition and also exponentials. This time it's going to be a little different. We're going to do the following. Now, you have a log x in the exponent and x at the base. They're not the same. The bases are different, so it doesn't simplify. But how can you take care of x to the power log x? Easy. You can log both sides. And logging both sides is the best thing you can do here. If you have something, so we can basically say this as a general strategy. Anytime you see x to the power log x, log both sides, because that's going to bring down the log. So let's go ahead and do it. Log this equals log that. Great. Now let's go ahead and bring this to the front. 1 plus log x multiplied by log x equals 6 log 10. Log 10 is 1 because base is 10, so this is 6. Now you can replace log x with something. How about t? T times 1 plus t is 6. T plus t squared equals 6. Let's solve this problem a little differently. T squared plus t minus 6 equals 0. The quadratic formula gives us -b plus minus the square root of b squared, 1 plus 24, which is 25, and that becomes a 5. -1 plus 5 over 2, or -1 minus 5 over 2. And that gives us t equals 2, or t equals -3. And t is what? Log x. Yay. Log x is equal to 2. X becomes 100. And log x is equal to -3. X becomes 1 over 1,000. Those are going to be the same x values. And here you go. The graph of x to the y equals 10 to the 6 and y equals 1 plus log x. Obviously, you don't see the intersection points, but if you think about it, they're going to intersect eventually at 2 points. And what happened at super duper small values? X equals 1 over 1,000 is not shown on this graph because it's super duper small. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.